Hello everyone again and welcome to this particular video, and in here we're going to be continuing from where we stopped involving Suzuki coupling reactions, and in here we're going to be focusing on a specific type of Suzuki coupling reaction where we're going to give an example and also follow up from what we talked about involving the use of an alkyne, and this alkyne is going to be interacting with a borane, and this actually leads to a specific type of reaction called the hydroboration, and this hydroboration is actually crucial in here. Why? Because is that it is actually leading to the creation of a specific type of complex that will later perform an type of reaction which is called the transmetallation after oxidative addition is occurred on one path of that particular reaction mechanism. So in here we're going to be applying this to octyne, and this octyne we know of course has 8 carbons, where in here on the first terminal there is actually a triple bond, and this triple bond here is going to be losing one of the pi bonds to form a fresh new sigma bond that will interact with our specific aromatic ring at the end of this reaction. So looking at the highlight here, the question is, what is the mechanism? And the mechanism here is given this type of reactant which is called the borane, and this is done in the presence of our octyne. In the presence of heat and water, you actually form an intermediate A. So our job is to determine what the intermediate is, and then once this intermediate is formed, there is a second step reaction which involves the presence of our violin, which is a Z configuration bromide, and this is actually done in the presence of our catalase with a base which facilitates a specific transmetallation step which speeds that up in a way, and also toluene, which is a solvent, and this leads to the formation of this specific type of product here. So this product here we notice is 2 configurations here. We have the Z and the E. Now which is which we don't know yet, but we know that one part is E and the other side is Z, and it is a diene. So how are we going to approach this particular step in here? This leads us to the mechanism, and the mechanism, in some path there is an oxidative addition, but we're going to clarify that in this video. But first off is we have our octyne, and this octyne is actually in the presence of heat and a step called the hydroboration. That is a keynote to take note of, because in here we know that borane is going to be involved in here, and our specific terminal high carbon is going to have that specific formation of a bond with borane after the loss of a pi bond and the formation of a sigma bond, and the boron hydrogen actually cleaves off in terms of the bond, and that forms a sigma bond between the hydrogen and the carbon right there. Therefore we have actually created our intermediate A, which is a specific configuration which is related to the regio selectivity that puts our particular component, which is the hydrogen and the boron, in the C's position. Therefore in here, once we have our intermediates, this C's confirms that we have our E violin boronic acid created, and then the next step is the important one, which involves the change of our oxidation number of palladium to palladium 2. So therefore this is actually done with the help of our Z violin boride. So therefore this actually leads to the formation of a boride palladium bond and our sp2 carbon palladium bond that is created right there. Therefore after showing the electron pushing arrows, we actually have our specific intermediates, and these 2 intermediates here where we have our palladium complex and our boronic acid complex created, we need our specific base to actually facilitate the next step, which is the transmetallation Therefore, our base, which is coming from potassium hydroxide, actually then in the presence of our solvent toluene actually leads to the removal of our carbon boron bond, and that actually then leads to our specific sp2 carbon forming a new palladium carbon bond, therefore causing the leaving of our bromide in there, and this actually leads to the formation of our new complex, which has two palladium carbon bonds, and this is an indication that we are going to create our final step, which regenerates our palladium 0 from palladium 2. So therefore, in here we have our particular carbon palladium bond cleaving to form a carbon carbon sigma bond, which is the new bond that's created, and then we have our carbon palladium bond cleaving to regenerate our palladium 0. Therefore, we create our specific product, which is our specific octane, and this octane has a specific formation that actually has our other segments to be positioned in the cis configuration. So therefore, we have a hydrogen positioned in the same direction as the other segment, which is a violin, but in here our violin is Z, and in terms of the regio selectivity, we have the combination of our E and our Z, which are separated by that sigma bond right there. Therefore, we have our EZ diene that is created due to the process of our specific Suzuki coupling reaction, where take note here that we selectively used octane, which leads to the formation of our E regioselective intermediate product, and with the introduction of our specific Z violin reagent, which is coming from the bromide, we can actually lead to the formation of our EZ diene combination in there. So that is about it for this particular reaction here, and take note that this EZ diene is actually 70% in terms of the yield, and this is useful usually in the Theodore reactions that we talked about on multiple videos ago. So on our next video, we know so far today in this video we talked about the hydroboration of octyne, and this is actually going to be leading us to the next particular condition to take into consideration, which is the stereo controlled synthesis of the EZ diene when it comes to those reagents given. And then our final video will be about the application of the aryl cross coupling and the aromatic heterocyclic coupling, where instead of having just all carbons, heterocyclic means that you're having something other than carbon like nitrogen or oxygen within that particular aromatic ring. So that's about it for this particular video. Hope you're able to understand this type part 2 of the Suzuki coupling that involves the hydroboration of our specific alkyne, and this is going to be done in future videos. And thanks so much for following me through this. Truly appreciate it. Hit the comment down below, let me hear your thoughts, and don't forget to subscribe, but that way you'll get caught up with the new videos that I post frequently in the future. All the same, stay smart as always, and always believe in yourselves.